Have you ever had something you really rely on, your car, your laptop, maybe even your coffee maker, just suddenly die on you? It feels totally random, right? It's frustrating, it's usually expensive. But what if I told you that it's not random at all? That there's a whole science dedicated to figuring out why things break? Well, today we're going to dive deep into the science of failure.
I mean, from the absolutely mind-bending complexity of rocket engines like these, where failure is just not an option, all the way down to the humble toaster sitting on your kitchen counter, the story of failure is literally all around us. And while a sudden breakdown might feel like a complete shock, for the experts who study this stuff, it's actually a predictable pattern. It's like a mystery, with all the clues hidden in plain sight.
So, that's the big question we're tackling, isn't it? Why do things really break? We're going to put our assumptions aside and just follow the evidence, kind of like a detective on a case, to find the real culprit.
Okay, so our investigation is going to start by putting the #1 suspect on the stand, the one we all instinctively point the finger at when something breaks.
I mean, it just makes sense, doesn't it? Your car's got a ton of miles on it, your phone is a few years old, of course it's going to fail eventually. We see this as the main reason for failure. Just simple, straightforward wear and tear.
But what if blaming old age is like solving a mystery by just arresting the most obvious guy at the scene, while the real mastermind quietly slips away? Yeah, the true story of why things fail is so much more fascinating than that. All right, to crack this case, we gotta bring in the pros. So welcome to the world of reliability engineering. This is the field dedicated to predicting and preventing failure. And their first clue for us is a huge one. We need to stop thinking about how strong something is and start thinking about probability. It's a game of odds.
So here's the formal definition, and the key word here is probability. Reliability isn't about being indestructible, it's a calculation. It's the likelihood that something will do its job for the amount of time it needs to, and in the environment it's supposed to be in. It's really a science of prediction.
Let's break that down into its 4 key parts. First up, probability. What are the odds it's going to work? Second, intended function. Is it doing the exact job it was designed for? Third, specified time. Will it work for as long as we need it to? And finally, specified conditions. Is it operating in the right environment? The right temperature, the right pressure? If you change just one of those things, the whole reliability equation changes with it. And this quote, wow, it just brilliantly illustrates a massive shift in thinking. Imagine a water pump. If the motor is running, but it's only putting out half the water it's supposed to, has it failed? Well, according to reliability experts, absolutely yes. It's no longer performing its intended function, so that's what we call a functional failure. Okay, so if reliability is all about predicting failure over time, how do we actually visualize that? Well, it's time to turn to the most famous tool in the entire reliability playbook. It's called the bathtub curve, and it basically tells the secret life story of almost everything you own.
And here it is, the bathtub curve. What you're seeing is an item's risk of failure over its entire lifetime. See how it has 3 distinct parts? There's a high-risk infant stage at the beginning, then a long, stable adult life in the middle, and then finally an old age stage, where that risk of failure shoots right back up again.
So let's look at these 3 phases a little closer. Phase 1 is what they call infant mortality. This is when things break early on because of manufacturing problems. When you get a brand new phone and it's a total lemon. Phase 2 is that long, flat bottom of the tub, the useful life. Here, the failure rate is low and it's constant. Failures aren't about age, they're random events, usually caused by some kind of outside stress. And then you get to Phase 3, wear out. Now this is what we all think of when something breaks. Parts are just getting old and wearing down.
For decades, everyone just accepted that classic bathtub curve as the way things were. But then, some researchers at United Airlines did something totally revolutionary. They actually went and studied the real-world failure data for thousands and thousands of airplane parts. And what they found, as you can see right here, was not 1, but 6 common failure patterns. Just take a look. The classic bathtub curve is there. That's pattern A. But look at all the others. The whole idea of wear out, where things are more likely to fail as they get older, that's really only patterns A and B. They're just 2 of many, many possibilities. So the big question, how many failures are actually caused by old age? Well, when they crunched all the numbers from all kinds of industries, the result was just shocking. Only 11% of all failures are actually related to an item getting old and wearing out. Just 11%. This right here, this is the twist in our whole mystery. A staggering 89% of failures are random. They happen during that long, flat, useful life part of the curve, and they have nothing to do with age. This means our prime suspect, old age, is almost entirely innocent. The real culprit, the one responsible for almost all failures, is random stress and just unpredictable events. This is why, by the way, extended warranties can be such a gamble. You're not betting against a predictable decline, you're betting against random chance.
So, if we can't blame old age, how in the world do we fight back? How do we manage this world where failure is mostly random? Well, it's time to meet the Detective's Toolkit, a framework called Reliability-Centered Maintenance, or RCM. It's designed to help us outsmart failure before it even happens.
Traditionally, maintenance has always been reactive, right? Something breaks, you fix it, the only goal is to get it up and running again. But this modern approach, RCM, is completely different. It's proactive. The goal isn't just to fix broken parts, it's to preserve the function of the whole system and to manage the risk of that function ever failing in the first place.
This quote from John Mowbray, who was a real pioneer in this field, it just says it all. RCM is a strategic mindset. It's about understanding what a system is supposed to do and protecting that ability instead of just standing around with a wrench waiting for something to go wrong.
So how does it actually work? Well, it's all about asking a series of 7 very specific questions. This is basically the detective's checklist. You can see you start by defining what the thing is supposed to do, its function. Then you think through all the ways it could possibly fail, what would cause it, what would happen, and finally you build a strategy to either prevent it, predict it, or just deal with it. It's a super logical, step-by-step investigation into risk. And the real power of this whole approach is that it completely shifts our focus. Instead of just reacting to bad things after they happen, we are proactively preserving function. It gives us a clear, logical game plan to manage that massive 89% of failures that happen randomly, instead of just waiting around for them to surprise us.
So the next time something breaks, don't just write it off as being old. Think about its function. Think about the random stresses it faces every day. And think about its real story of risk. From your car to your phone to your washing machine, what in your world is secretly living its life on the bathtub curve?